So the other day I picked up my two maps from the printers. One is the Gleason map and the other one is a large copy of the AE map. You can see just how big it is compared to the R2-D2 and my Mavic Pro drone. Now, when you have a look at it like this, there are just so many things wrong with this being a physical representation of the shape of a flat Earth. If you understand that these maps are actually projections from the globe, you can understand why there are so many distortions of the continents south of the equator. Where the mistake lies is when people try to tell you that this is actually what the physical Earth looks like, because there are so many mistakes with it. And what I plan to do in a series of videos is just identify some of those, aside from obvious things such as the ridiculous width of Australia compared to the USA and different flight paths that just simply don't work correctly on this map. I'm going to also look at the motion of the sun, and I did that today using my Mavic Pro drone just by fitting a small ping pong ball on top. And the experiment was to simulate the path of the sun moving around the equator as it would on the equinox and being viewed from a position of Sydney, Australia. Now, I realise that many flat earthers have given up on this model, and in fact there are many flat earthers who have debunked this model, so these guys have really done their homework. But there are some people who are still clinging to this map as being the physical shape of the Earth, and it's just ridiculous. And to be honest, when I first saw this map 18 months ago and somebody said that's what the Earth looks like, I thought it was a joke until I realised they were serious. But let's consider the more common model where we have a 32-mile sun circling 3,000 miles above the Earth. And let's have a look at how we can simulate that with a scale model, with the drone carrying this sun around and seeing if we actually do get a sunset. So for this experiment, the sunset experiment on the AE map, we're going to use 1 degree of latitude as being 69 miles in distance, that is 60 nautical miles. So if we measure from the North Pole to the equator, we have 90 degrees times 69, that gives us 6,210 miles radius from the North Pole to the equator on this flat Earth map. From the North Pole to Sydney, Australia is 34 degrees south latitude. So that's 90 plus 34 gives us 124 times 69, that is 8,556 miles from the North Pole. So for this experiment, we're going to build a scale model and we're going to use 1 millimeter to represent 1 mile on our scale model. For this standard AE flat Earth model, they tell us that the sun is 32 miles in diameter. So on a scale model, that would be 3.2 centimeters diameter, about the size of a ping pong ball. Ping pong ball is just very slightly larger than that, but that's close enough for the purpose of this demonstration. The sun height is 3,000 miles. That will be 3 meters on this model. The distance from the North Pole to the equator will be 6.2 meters, and the distance from the North Pole to Sydney will be 8.5 meters. So that's the model that I set up using my Mavic Pro drone. So there's the ping pong ball. It's just very slightly larger than a scale 32 miles, but it's certainly within a few percent. And the app I was using on the Mavic, it's not the standard DJI app, it's a more advanced app. It's called Autopilot, and it allows you to fly precise orbits. And there you can see I had the orbit of 3 meters altitude and a 6 meter radius pattern around the target during the experiment. And you'll see this in the video shortly, but just to explain the experiment, I measured 8.5 meters with a tape measure to this orange carry case for the Mavic, and that was the center point of the orbit. And I was also able to place the camera at ground level, and in fact you'll see that I place it slightly below ground level, so nobody can accuse me of having the camera well above what it would be on a scale model. It was down at ground level and in fact below it. And as you will see, at no point did that sun disappear during this experiment. So there is no sunset on the AE flat earth model. So I'll just show you the setup here. It's an 8-metre tape measure, measuring out along the cricket pitch, and then I've got the case about another 50 centimetres beyond that. So 8.5 metres represents 8,500 miles, which is the correct distance from the North Pole for Sydney, Australia. So we're simulating the view of the sun moving across the equator, around the equator, as it would on the equinox, as seen from Sydney, Australia. So the drone is once again circling, and it's circling at a height of 3 metres and a radius of 6 metres around that orange case. So it's simulating the motion of the sun on the equinox, and the viewing position is simulating Sydney, Australia. So there's midday, and then the drone is going to move away. And what we're looking for specifically is, will the sun appear to set on this scale model? So what I'm going to do is just make sure that we're not cheating. I'm going to put the camera low enough so that that orange case disappears. And has the drone disappeared? No, we can still see the drone, which means we can still see the sun. So even though I've got the camera low enough that it is below ground level, we can still see the sun. So there's no sunset on a flat earth. Let's let that come around again. Okay, try and get the camera nice and smooth and in focus. Get it just below ground level so we can't see that orange case, and yet we can still see the sun. So even with the camera below ground level, there is no sunset on a flat earth. So as you just saw in that demonstration, even with the camera below ground level so that we could not see the orange case, at no point did we lose sight of the drone and the sun. So on the AE model, with a 32-mile diameter sun circling the Earth 3,000 miles above the Earth from Sydney, Australia, we would never see the sun going below the horizon. There would be no sunset on a flat Earth. Now, if you're closer to the equator, the situation becomes worse, and the closer you move to the North Pole, the worse it becomes, because you're then always going to be closer to that drone, which means it would be higher in the sky. So there'd be even less chance of the sun getting anywhere near the horizon if you're in the Northern Hemisphere. Now, I do realise that we used 69 miles as 1 degree of latitude, and I'm aware that some flat earthers who support the AE map will tell you that the circumference of the equator is 24,900 miles. Now, if that is the case on a flat earth, it means we have 44 miles per degree of latitude. That means the distance from the North Pole to the equator is 44 times 90, 3,960 miles. To Sydney, Australia, it's 44 times 124, 5,456 miles, North Pole to Sydney. If I were to model this demonstration using those numbers, it only makes it worse for the flat earth, because the drone and the sun would be higher in the sky. Even at the furthest distance, there would be less chance that it would actually approach or even appear to disappear behind the horizon. So this is a fairly easy demonstration that proves there would be no visible sunset with a sun doing circles above a flat earth that look like this.